Can you solve this problem on nuclear chemistry and radioactivity? The question says that cobalt-60 used as a radioactive source for the treatment of cancer has a half-life of 5.27 years. How many milligrams of cobalt-60 will remain after 42.16 years if the initial supply is 500 milligrams? So how do you go about a question like this? Now, so let's see, this is the solution. This is the formula you need to have off head. Then N naught over N equals KT. And so the question is, what is N naught? N naught is the initial amount that was supplied. So from the question, we see that N naught, that is the initial amount, which is 500 milligrams. So N naught is equal to 500 milligrams. And then we also have N, which is the amount that will be left after time T. So the question is asking us to find how many milligrams of cobalt will remain. So N is what we are trying to find. Okay, and then we are given T, which is time T, to be 42.16. So we are given T, which is time, to be 42.16 years. Okay, 42.16 years. So if we take a look at the question, we can see that we have N naught, we have T, and we are trying to find N. Now we also need to find K. We don't know what K is. Now K is the decay constant. So K is decay constant. And how do we find K? K is equal to 0.693 over T half. Now this, let me call this equation 2, and let me call this equation 1. So these two equations, you need to have it off head. Okay, so from this formula we can find the decay constant K. K is equal to 0.693 divided by the T half, which is also given to us. T half is the half-life, which is what, 5.27 years. Alright, so we have 5.27 years, and if we punch this in the calculator, we should be having, let me quickly punch that. We should be having K to be equal to 0.1315. So that is our decay constant. So all we need to do now is to put this value in the equation, and then we are good to go. Now we have ln N naught over N to be equal to KT. Now the K is 0.1315 times T. The T is what? 42.16 years. Okay, all right, so this will give us ln N naught over N to be equal to 0.1315 times 42.16. This will be equal to 5.5 5.54. 5.54. Alright, so right now what we want to do is to get rid of the ln. Now if we take the anti of the ln, that we're going to be having n naught over n is equal to e exponent 5.54. 5.54. So what you want to do now is to make the n, the capital N, the subject, and if you do that, that is going to give you n naught divided by e exponent 5.54. So this will be equal to n naught is 500, and if we put this into the calculator, we are going to have 2.54, and this will be equal to 1.96. So this is the amount that will be left after 42.16 years. So I hope this video helps you. Watch out for more questions of this nature on radioactivity. Thank you.